So hello everyone, and thank you to join us for this uh, next edition of the YakRover weekly meeting. For the past 3 weeks, we've been drilling on what we could prepare for two things. First is for the demo day at the end of the year, and we are talking about trying to do some field testing, so to have rovers in a practical situation out there. Also, how to work together and to build something bigger than each of us can achieve. And we've been talking about software as the distributed nature of the team makes it much more easy to use software as a ground for collaboration, but also because last year we've mainly worked on different builds, on hardware, on mechanics, power electronics, and we see that there is much to do on the software side, especially when considering um, remote missions like space, but also in many applications we can see robotics on Earth, okay? Where autonomy in terms of energy, in terms of driving and so on, becomes are real challenges even today. So maybe we can contribute there. Okay, so last week we discussed three items, okay? And so one was the need for communication between agents, where an agent is either a rover or a human, okay, for example, to give a goal, or some item we may need like a base station. Okay, so there is need to communicate here, and there is a proposal around based on some Venkatesh comments. Okay? So basically, it's about what kind of protocol do we need, so that the communication between the rovers, all the agents. Okay? The second out of three, the second thing we talked last week is to, with what we have, the technologies we have from the web, from software and so on, can we have a bottom-up approach and make some proposal about what to build, okay, to address the different issues we have. And so Red has a thread on GitHub on which several of these points are discussed. Okay? So that's really about a more pragmatic approach about how to use what we know and to maybe to identify what we need. Okay? And the third point out of three is about how to perhaps structure the software inside a rover, inside what we call an agent here. Okay, what are the different components we would need to make it possible? And so the idea of identifying the internals of an agent is to see what kind of software component we need and see how we could collaborate to make them. Okay, so a bit long introduction of what we've been doing so far. Okay. And today, it's more a discussion about how to put all that together and see whether we can identify things to do together. And so last week, the last thing we looked at is this image, basically, okay, on how things are put together. Okay, so briefly, in blue at the bottom, we have a build. So it's a hardware. It's one of our rovers, maybe another one. And we've been discussing about the yellow parts these days, about an API, a software API, on how to program a rover. Okay, and so last year we had several independent endeavors, okay, where we have custom software for custom hardware. Okay, so we had the yellow and the blue part on this picture. So the thing that we are trying to see here is that can we make an API that is common to all of us? So a software library that covers the yellow part that we can all use. But then to use that on each of our rovers, we will need to adapt that software to the specific software, the specific hardware we have. Is it a Raspberry Pi? Is it a BeagleBone? Do we have motors? Do we have legs and so on? Okay, and so this is where the adapter comes into play. Okay, so it's another software that is specific to a build, and in terms of software engineering, it implements the yellow API. The last piece is the green block. The green block captures the control software we have typically in robotics. Okay, so is typically the app, okay, what the rover is supposed to do. Okay, like if we take a curiosity, there are several apps. Okay? One of them is to navigate. Another one is to collect samples. Okay, things like that. So this is where we stopped last year, and I'd like to stop for a second to see if there are questions about that. But basically, the rest of the document is to dig on this point and to put together everything we've been discussing in the past 3 weeks. Is there any question, any comment at this point?
I think the only comment or kind of notable thing that came to mind when you were describing them is that I don't necessarily think that the API piece has to be a reusable piece of software that everyone has to run. More of like, this is the standard with how we communicate, and that can be implemented in many different ways that we may find, and I hope that we find that we can share like those implementations, because obviously it shares work, but I don't think it, I think we should make sure that we don't get ourselves in a position where we like have to use the exact same software stack to work. Does that make any sense?
Yes, it does. Thank you very much. And so this is something that that leads to my next point, actually, because there is something missing on this graph that I made a month ago. Okay, here there is no communication with the outside. Okay, so here actually there is a fifth one called comms. So here the API I'm talking about is about what is inside the rover. Okay, so let's say we at this point we ignore communication. There is no communication with other rovers. Okay, here is just an API on how we would program applications to do something with the rover. So let's say that I have some algorithm to do some navigation from A to B. Okay, so it's let's say something like an A-star algorithm. A-star is a typical algorithm to solve such kind of issues. Okay, let's say I have an implementation of it. It would be good that we write it once, okay, against the yellow API here, and so it's in quotes, okay, that we can reuse it on many of the rovers. Maybe not all, because we have some hardware constraints, like some of us are using microcontrollers, okay, but the idea is to try to have reusable component to some extent, okay? And that you see there is no communication at all with other rovers. Okay?
If that's the case, then if I'm understanding the distinction you're making correctly, what you're calling an API is more like MLIR or something, like the mid-level intermediate representation, something like that, like at the LLVM level of abstraction, whereas the comms piece that actually has inter-agent communication, that's more like what we commonly think of as an API. Is that fair? That this is really an intermediate representation, a couple of abstraction levels above machine code?
So yes and no. I think we just need to agree on what we want to say. For me, API is an SDK, if we want here. Okay, the yellow block. Okay, API is a application programming interface. Okay, so for me, comms, when we are talking about an autonomous entity or something we want to be autonomous, like a rover, for me the comms can't be an API. It can't be a programming interface. We can just have queries and answers. Basically, we can ask, okay, please do this. But the rover may not comply because it comes from outside, and so for its own safety and maybe for security reasons, it may decide to ignore it. That's why recently I've been talking about, okay, so it is about RPC, okay? Because if we want comms to be like RPCs, yes, then it's an API because of the nature of what RPC is. These are basically remote commands, okay? And they are not negotiable in a way. While
so let me ask the question another way. I think I'm still not quite like we're using a lot of terms loosely. So RPC, API, intermediate representation, comms is kind of a different category of like term. It's more from common language than technical language. And maybe a way to get clarity on what we're talking about here is the app. Does it look like a virtual machine, or does it look like a program that makes some function calls? What world does the app think it lives in? Does it believe it's in control of the environment? Does it believe it's living inside a virtual computer? So is it a container? Is it a VM? Is it kind of like a program running on a shell? Like, what does it?
So whether it's a container, a VM, or a shell program doesn't really matter to me, because they are equivalent. Okay. A virtual machine. Okay. I mean, in terms of software, and Red and Victor, please also interrupt me if I'm really wrong. Okay. But we can write down a program after, whether we package it and deliver it as a container or a shell script or just a plain program. Okay. That doesn't change the nature of the program. It just changes the way we are delivering it, basically. Okay. So the green part, what I call the app, is typically in robotics what is called the control software. Okay. Some people will even call it the brain, if we want. Okay. So it's the scenario we want the rover to run, in a way.
Okay, maybe I think I'm still missing a piece, because to me there are distinctions when you talk about terms like VMs on the one hand and other kinds of programs. And part of it is, I think, the relationship to real time that the program experiences. So there are programs that live within a fiction that they're living in real time. But really what they're getting is extremely fast thread switching or something like that. And there are programs that literally do have monopoly on the processor, and therefore have kind of monopoly on the physical actuators and feedback loops. Is that a useful distinction to make? Like, is an app typically going to be kind of an event-driven asynchronous thing that lives in some sort of extremely soft real time? Or is it more likely that the app is going to experience something close to real time?
So to me, that's a very important and very interesting discussion. But in the term this year, I believe, in a way, I consider that it's too advanced or too specific. Here, it's more about, okay, we have builds, okay, and all of them are running some flavor of Linux or whatever. And what can we do with that? So basically, the build, the blue brick, includes the mechanical build, but also the board, the SBC that is on board, okay, and that includes usually the let's say the classical operating system into it. So after, on top of that, we have an SDK which is basically the API and the adapters, okay, and our logic, which is in the app. Okay? And so in that sense, whether it's a VM, so how we wrap the adapter, the API in the app, whether we wrap it as a virtual machine or not, it's whatever the underlying operating system can support. It doesn't make a difference in that sense. Okay? In the frame of this document and the target toward the demo day.
I think if my understanding would be that going from the bottom of the stack up, the rover, any specific rover, it's exactly that hardware. So the build layer is very specific to an individual rover's hardware. The adapter makes a lot of sense to be running on the rover itself at a minimum. Like that seems to be highly tied to that rover's hardware. The API, if you really wanted to, you could probably put it somewhere other than the rover, and it would send lower level commands back to the adapter on a rover. But it would still, like if I was implementing it on mine, I would put the API server as opposed to that implements the API spec probably on my rover, since I have a general purpose CPU there. And then the control software, as we're implementing it, could probably be just about anywhere as long as it can talk to an API server. Does that make sense?
So it does, but there is. So it's possible, of course. That's something that is an option, okay, with several benefits. But here, API, I'm using API because I'm old, okay? So I'm using it the old way. An API is an abstraction programming interface. It's an interface, as in interface in Java, for example, okay? So it's a bunch of classes that have to be implemented. So there is no notion of active server and so on. It's a purely static software contract that we agree that each rover agrees to implement. Okay. So for example, I can have a class. Let's say in object-oriented programming, I can have a class called a sensor. Okay, and a sensor has a typical interface. Okay, to say okay, it's a read. Sensor typically is we have a function that we call read. So that's an abstract sensor. And so the adapter would say, okay, my rover has a temperature sensor, and it's a this spec. Okay, and so I implement the class sensor, and I will say read will do that action. It will read the sensor, read the bytes, and pack them into some data structure to pass according to the contract of the API. Okay, so sorry, I'm using the old word of API. Okay, now it usually means a REST API or whatever, but I avoid that terminology on purpose because REST is communication oriented, and this is all inside the rover. Okay, it's like its guts in terms of software. And so, of course, this API can also be dynamic in the sense that we implement it as an option through a web server, and it can be remotely connected. I think that's great for several scenarios. Typically for remote control. Okay, if we want to do some remote control scenario, arrays and stuff like that, for example. Do I make sense, Victor?
Yes. Yeah, I just I'm used to network-centric APIs, so
yeah,
that was the first thing my brain.
Yes, in our connected world, definitely.
We could define the stack in an abstract enough way where both definitions work, and you could have implementations that work in sort of a classical OS API sense, as well as a modern network is the computer sense. And in the latter case, what would end up happening is the stack would be something like, I would call it a software-defined rover. Like, you have software-defined networking or software-defined radio. This would be a software-defined rover where it's actually extended across 3 physical devices: an actual physical moving object, a server that hosts the API, and then maybe the top 2 layers in a different command thing. But the whole thing would form one logical rover, and maybe you would call the bottom 2 layers something like a headless rover or something like that. So some interesting possibilities are emerging here, and I think we could sort of leave the canvas open to all those developments.
Oh yes, yes, Venkatesh, it's exactly why I'm using very abstract terms here. Okay, but I would say that now listening to what Venkatesh just said, here API means headless. Okay, I mean most people now use API, but it's actually a shortcut to mean a REST API or something like that. Okay, here is the old style, but I think in the modern terminology that would be a headless API, the yellow parts. Okay, and just very frequently, I'm taking the example of just what it means to go forward. Okay, and I think it's the label on the left. Okay, that's part of the yellow API here. Okay, is that what does it mean to go forward? Okay, and it looks obvious. Okay, but I tried actually exactly 1 year ago. I have a repository related to YakRover on trying to implement that API. And I implement one endpoint that I call forward. Okay, and if I try to have it generic enough, that is to cover wheeled robots, legged robots, but I was also trying to imagine, okay, what if it's a drone, or whether it's an underwater rover. Okay, and then I stopped. Okay, because that's the ramification starts to be pretty complicated. Okay, but this is the idea is that the API here is about defining a contract. Okay, is that that is the rover defined API. No, the software defined rover. Okay, is a rover needs to be able to go forward. Okay, there is a contract. How it does it? That's the problem of the adapter. Okay, but I think part of the work here is to be able to identify what forward means, what backward means, and others. And others is it's not an infinite number of actions. Is what makes a rover basically. Okay? So, for example, if the entity can fly, is it a rover? But then if it can't fly, is it still a rover? Okay, it's the ability to maybe to decide the scope of what I call here the API, and maybe we can call it the SDK API if it's clearer this way.
Sorry, I want to go back to something Venkatesh asked. So, Vet, you go first.
I was just going to say, I think I'm understanding now the level of abstraction that we're talking about. API is, or do you think API is equivalent to the language discussion that we've been having off and on? Like, is that, could language actually be the label for that?
That's what it says.
Right. Yeah.
Okay.
You should actually closely read the labels.
Okay, thank you. But in the recent discussions, I think the language, the term used by Venkatesh, during his discussion, he also mentioned that perhaps protocol is a better term than language. Okay, and so this is not that at all. Okay, here is the yellow block, the what I call the API, is basically the contract. It's maybe we should just skip the word interface. Okay, interface as in interface in Java in particular, because it depends on the language again. Okay, so it's about function names and the parameters they need and what they will return. Okay, so in Java it's called interface. In Objective-C it's called a protocol. Okay, so it starts to get confusing. Okay, but this is what I mean here. Okay, so it's typically what a contract is. Okay, either what are the handles, okay, what do they need and what do they provide. So it's not in software, usually we call that framework. Okay, as part of a language. It can be implemented in different languages. Okay, so I hope it will bring some clarification, right? But I'm not sure.
I think it's difficult to talk about because there's so many different levels that you could be talking about it from. Like, we could literally be talking about the Java interface that implements these things. But I don't think that's where it's going.
But the basic idea to keep in mind that basically when we make a rover, okay, what we're looking at is the ability to make rovers to address any kind of scenario. Okay, and so a scenario is an app basically that we implement on a rover. And so the app, we don't want to build an app from scratch every time. This is what we have been doing so far. This is why ROS has been successful, because it provides a framework where we don't build an app from scratch. There are a lot of facilities available. And so the idea here is to have, is to be able to be, how can we make an app for rover with, in quotes, as little work as possible? Okay. And for that, usually we provide a framework in which we, that makes assumptions, that is opinionated sometimes, okay, on how an app should be, or should, what it needs basically. And we provide what it needs. And what it needs is what is called here the API. So to give an example, in web, for example, a lot of people are familiar with Rails, Ruby on Rails, okay, which is losing popularity and so on, okay. But Ruby on Rails is a framework to build websites, okay. So it provides a lot of facilities, okay, to structure in an opinionated way a website server code, okay. So typically it's the MVC pattern, the model, view, and controller. Okay, so it splits things this way. And after that, we don't have to build it from scratch. We just build the view we want, the controller we want, and the models we need, and Rails will take care of the rest, basically. Okay? So in that sense, Ruby on Rails is something like what I call here an API. Okay, and the website is the app, the website we want to build. So does it make sense?
I think so.
Thank you.
So I'd like
Yeah.
I'd like to get back to what Venkatesh asked. What time does a rover live in? Is it hardware time or software time? And I think the answer is neither is a correct thing for a rover running apps. In other words, if you're in the real world, and let's say time is measured in tens of milliseconds, you need to be alive the whole time. Otherwise, something can happen to you. If at a lower level, the microprocessor gives 1 microsecond to one application, 1 microsecond to another, that doesn't mean anything. But the rover is a rover, or an app, can't just abdicate the processor and hope that a few seconds later everything will be okay. But on the other hand, when I say can't, there's different levels. In other words, let's just imagine a rover that's walking and chewing gum at the same time. So I have one app that's doing the walking, and I have another app that's chewing gum. Well, the one that's walking has a part that does planning where it's going to walk. That doesn't need to be alive all the time. That can go away for seconds at a time. It has a part telling the legs where to go. And there's also a very low-level part which handles every single step. For example, if it steps on a rock, it changes what it's doing. If it suddenly a T-Rex comes in front of it, it has to respond. That was not a good example. If it steps on a rock, it leg whatever. I'll get back to T-Rex. Don't worry. So different levels of the app need to live in different time frames. And if we take again the example of chewing gum, the part of the app that's in charge of chewing gum has to have the same tens of millisecond real time as a walking, because if you stop chewing, the gum can stick to your teeth and you get stuck. Now, this is just, what's planned. But you also have what's unplanned. Suddenly a T-Rex appears. Well, if a T-Rex appears, there's two things you have to do. One, the way you walk is going to change. You don't want to bang into T-Rex. But there's perhaps some executive function that says, okay, what can I do as a T-Rex? So it might say, take out the chewing gum and throw it at the T-Rex. So the app that's in charge of chewing gum and thought that it was, independent of everything else. The way, on my computer, I have Zoom running, and I also open the window to look at the link that Venkatesh sent. And these two applications are independent. Well, they're not. The rover is an integrated system. And if something happens, it has to respond to it. And responding might mean not only preempting CPU, but actually changing the goals of each one of these apps. So I don't think the time model you were talking about is a useful time model. And perhaps to summarize, on the one hand, each app is working simultaneously on multiple levels. And second, we have interactions between the apps and events which by definition are going to change the time we're working at. And of course, this has to somehow be in the hardware architecture. because we're talking about rovers that are in the real world, where we have no control over the events and over might happen, might be needed. So, different position.
Quick comment on that. I think your comment was mainly about sort of the ideal time model for a potential rover. And then we have to ask, to what extent can we realize some version of that if we accept the constraint that for this year's experiments, we're building on top of Linux as opposed to writing something that penetrates Linux's time model, right? So there's like two separate problems here, this year's problem and sort of the ideal problem.
I don't see a problem there because Linux is so fast compared to the real world that it doesn't matter if Linux spends 50 milliseconds moving the right leg and another 50 milliseconds chewing gum. Okay, from the robot, from the perspective of the, let's call it mechanical side, that's meaningless. We do have to make sure, of course, that data is processed quickly enough. But if we look at a typical rover that has 2 legs and can talk on Zoom, like one of us, we work on a very slow cycle, okay, 100 milliseconds. Yes, you have prepackaged commands, but decision-making is very slow. You have some reflexes where you have preemption, but you know, every operating system allows that. If you suddenly do like that with your hand, your eye will blink. So that's a very short cycle at a low level. But if I say something, it might take you 3 seconds to realize that I brought a T-Rex into Mars. Okay, that is very slow. In that time, Linux can, you know, spin up and spin down 1,000 threads. So Linux is not an issue. It's all model and how we build the software to take into account that the time model is not time sharing and is not batch and is also not pure real time, because we do want the rover to be multi-purpose.
I think I had kind of one comment that to follow up on what Meyer's saying. Working with an API and implementing it across multiple rovers, we're going to encounter things that make that relatively imprecise. For example, if I tell my rover to move forward 10 in API terms, and Rhett tells his rover to move forward 10, is that actually going to be the same thing? Like, are they both going to move exactly the same distance at exactly the same speed and so on? We could attempt to address that with calibration. That would be addressing it at a lower level. And then the higher level program doesn't need to, it can have a little bit more faith that moving forward 10 means the same thing regardless of where it's running. Otherwise, if we don't trust that we can calibrate at that level on the hardware, then the controller or the control software needs to be a bit smarter. I feel like it would need to know, well, I told this to move forward 10, but we're still not at the objective, so I'm going to ask it to move forward 5 now. Do you see what I'm saying there? Like, this is a practical implementational issue when we actually implement this.
Yes, Victor, that's a very important point, and that's actually the main reason why I stopped working on that last year. Okay, what I mentioned, I have an API that, okay, just forward. How it's done depends on the build, but what are the parameters I need to give? Do I need to give a speed? Do I need to give a distance, and so on? Okay, and so after some time, I thought that that was more difficult, and here's the reason why. Is because of everything I've been talking about after that. To me, you know, we hear often that software is eating the world. And I wonder whether more and more, because of applications like Rover and robotics, whether now hardware is not eating software for that very reason, in the sense that the software depends on the underlying hardware anyway. Okay. And so, okay, sorry. This is where the
just a second. Before you go on, and I just want to say that the questions that Victor raised about how much do we trust the lower level, I just want to point out that we have an assumption here that there should be higher levels and lower levels, and we should have some sort of hierarchical structure, which basically says brain decides to walk to the corner of the room, and then there's a lower level which decides to use the wheels at a certain speed, and a lower level which controls the voltage, and another lower level which measures feedback from the slipping of the wheels on the floor to make corrections. Okay, so we're making that assumption, and I'm not saying it's wrong. I just want to point out that that's an assumption. And exactly considering the issues that we don't know if we can do it well or not, I'm just saying we should maybe question that assumption. What's interesting here in this context has to do with language. In other words, the minute we define the higher level command as go forward 15 steps or go to the corner of the room, that kind of suggests that we should have this kind of structure. Now you can imagine a different high level language, like, I don't care how, but in 3 seconds, I want you to be in that corner of the room. I'm not telling you to go forward. I'm not telling you how to do it. I'm not telling you what feedback. Okay, it's a different language, and I can imagine, though I can't imagine the actual language, other ways of having a high level of representation, which is suitable for rovers, but doesn't match our current hierarchical imagination of what's happening inside. So again, I'm just pointing this out. I'm not saying that for our purposes, we shouldn't use exactly this solution, but we are exploring. So I want to point out where we're not going.
And so sorry, I'm not sure I got to the point. I got the point, but there is something that you said that to me is very important and really valid here, is that sometimes I'm considering the option not to care. Okay, is that going forward, does going forward 10 needs to be consistent across rovers? Okay, so I'm just wondering, okay, because when we talk about the language here, so I think this is the communication we are talking about, okay? And so go to the corner within 3 seconds. How we do it, how the rover will do it, we don't care so much, okay? We care about maybe safety and not distracting anything on the way, okay? But that's about it, okay? And so those are implicit constraints on what will happen, and also implicit constraints on the precision without it being explicit on what those precisions are. Just be in the corner, okay? And so edit the corner within 5 or edit the corner within 10 without units on purpose. It's like a compromise. We are okay. And so then does forward needs to have a parameter to say it will be forward 10 or forward 5? I'm not completely sure. But anyway, there is another aspect that another word that Victor used. It's about calibration. Okay, and another thing I started to look at. I don't have much to say. It's about having an API that is configured relative to the body, to the build. Okay, is to say, okay, Forward 10, it's 10 relative to the body. Okay, so there is a normalization that happens and that translates this 10. A small rover, forward 10 will be interpreted as forward 100 because that rover is small. Well, a big rover will get forward 10 and we interpret it as forward 1 because it's big. Okay. And there are some works about such kind of normalization. And guess what? All the approaches we are talking about are data-driven. Okay. The thing that I'm trying to start iterating on, all the data needs to be standardized and normalized in statistical terms. There is a lot of connection there.
Having done a little bit with having a rover try to figure out how to move around a room itself, I find it difficult to believe that we'd get a high degree of precision in any one of our builds in terms of how it would move. And I mean, this is just purely pragmatic. And it seems like maybe having the rover be more like a human that's kind of learning. I mean, even when we walk around a room, sometimes we bump into things and have to readjust our course or whatever. We don't get the full picture on what we need to do and map it out in detail before we move. It maybe if the rovers basically, we have an implicit understanding that the rover is going to need to course correct a lot, and that its brain, it needs to take that into consideration, then it would be sort of a relaxed constraint. We're not worrying as much about time for right now. We're worrying about eventually getting over to the target. And even if you say forward 10 and your particular build tends to move a little bit to one side or the other when it supposedly goes straight forward, then it can still adapt and reach the target regardless of its eccentricities.
Yes, it sounds like put in those terms. It's we trade precision for adaptation, or we use adaptation not to care much about precision. So that would definitely affect the range of applicability of such approach. Okay, but when we think about, for example, navigation in unknown environment, what else well, such category of problems. Precision may not be that important, in fact, right? It's like going on Mars, going from one area to the other, or inside our rooms to go in the corner within 3 seconds. Precision is a pretty vague notion, right?
I think when we end up talking about precision, it's really because we have not yet made the architectural choice between kind of like a declarative goal level alignment between agents versus behavioral coordination levels. Like the only time precision actually matters is something like, very precise formation movement or something. Then you care that you literally have to be aligned within like so many millimeters of each other, otherwise you'll crash. But without that, the two architectural choices are, one is we both need to get to the corner of the room, and so long as we understand the terms in consistent enough ways that we both achieve that goal within the constraints, that's fine. So that's one way to think of it. The other way is you need to care about precision because one of the rovers is much dumber than the others, and the smarter rover has to give it very precise micromanagement instructions. Otherwise, the dumber rover will not be able to do it at all. So those are the two cases I can think of. One would basically be kind of like autonomous peer-to-peer high-level coordination. The other would be kind of low-level master-slave architecture patterns. So once you choose between those two, the precision question, I think, kind of sorts itself out. You choose the model of precision that that is required by your architecture, right?
Architecture and application.
Yeah.
Mm-hmm.
I'll give you one example of extreme precision where it is required, which is the interferometric telescope. So this is what I worked on for my PhD. Here you must have like space telescopes like Hubble, so multiple of those flying in extremely precise formation, where the distance between the spacecraft is precise to the order of the wavelength of the light you're using to measure like the telescopic observations. Now, in that kind of scenario, precision matters in an absolute sense. But if it's not that kind of scenario, precision is a function of, like you said, the application and the goal and the alignment architecture.
I have to ask, we need calibration, but why do we need precision?
But we need precision. For example, if we take Curiosity, maybe we don't need so much precision when we are navigating. Okay, and however, when we have arrived at this, let's say a sampling site, the sampling operation maybe needs precision then. So for such kind of application, precision becomes necessary discussion.
Another example people talk about a lot, I've not worked on this problem myself, but when you have coordinated mechanical actions, like two robots are lifting something together, where it has to be kept precisely level, otherwise, some liquid might spill, something like that. So two robots together are cooperatively lifting like a delicate thing of liquid. Then they have to agree on precision with which they will be horizontal, right? So that kind of application also, a simpler example, this one I saw from search and rescue robotics. When you open certain doors, you have to like push down a handle and turn another knob at exactly the same time. So that's another kind of like precise alignment that you need. So those are all precision applications.
I agree that robots have precision applications, but it's not what makes them rovers. If you look at a beetle walking on the ground, so it has a lot of the walking solved using biomechanics, which are not precise at all. Let's call it muddling through. It is trying to get somewhere. And if you look at
but you see, there is sorry if I interrupted.
That's fine.
Sorry, thank you. For roving, there is something very specific to roving. Okay. Let's say that we have to go from A to B, but the only way to go from A to B is to walk on a beam. Okay. So, well, then precision is at the beam level. Okay. If the beam is 1 meter wide and our rover is tiny, yeah, we need a meter precision.
Well, that's a great example, because if we take an ant, okay, and we say it has to walk on a blade of grass, okay, similar sizes, the ant is built so that it'll be able to walk on a blade of grass. But if we draw a line in the sand and tell the ant to walk along the line, it's not able to do that, because ants don't need to be able to do that. So what I'm, again, I'm being inspired by nature, where nature gives us not so much precision, but ability to do tasks that it needs to do, but only at the qualities that it needs to do them. So I completely agree that there's some type of calibration. First, at the level of the rover, because whatever the rover wants to do, it has to somehow be able to do. And second, at the level of the language. In other words, if I tell the rover, walk along a beam, doesn't matter how I get there, the rover should be able to do that. But I'm questioning whether I need to be able to tell the rover these things. And I'm worried that what we're doing is we're taking a typical top-down specification method, and we say, okay, we need to be able to give this, so we need the API to be good enough for that, and then we have a lower level, and it has to be good enough for that, which is great when you're writing software, but perhaps unnecessary when you're designing a rover. And by putting our effort into that, like the very question, should the rover know the difference between walking 5 steps and walking 10 steps? That's not easy to do, right, Victor? Telling the rover how far to walk, it's not easy to do. I'm not sure we need to do it at all. Okay, maybe all the rover needs to do is know how to take 1 step, and then everything else is handled at a higher level. Either the rover gets to where it's going or it's not. And on the flip side, we talked about accuracy and opening the door. If I'm making a general purpose robot, it has to be able to, coordinate its hands and so on. But if I'm making a robot that opens doors, I will build a dedicated mechanical device that already includes everything you need. So when you press a button, it opens the door. So in both sides, I think we're getting carried away by some very general vision of what we want to do. And when we're doing this general vision, we're just adding more requirements into places that they're not needed. So again, I don't have a prescription what to do. I'm just, saying we should notice what we're doing.
So just a quick comment is that usually when we don't know what to do, best is to reduce the scope. Okay. However, we also need to keep in mind that sometimes by reducing the scope, we remove very important, very fundamental issues. Okay. So I don't have more than that to say at this point. Okay.
I'll take a task to sort of lead a special session discussion on timing models, since it's an interest of mine. I think it's more than we can get into in this high-level discussion, but it's worth a deep dive, I think. Just talking about precision and accuracy, especially when it comes to time coordination, because space coordination and other kinds of coordination end up being like a function of time coordination often. So worth a special session. So I think we should have one, actually. It's kind of an interesting topic anyway. So,
indeed.
Mayor, do you think that dealing with, I would call these just higher level applications, like Rover can rove, the API is, then please set your goal function to some other parameter, like, I don't know, they're not in terms of going forward and backwards. They're higher level things like look for green objects. I don't know, whatever it is. Do you think that being able to support applications at that level of abstraction precludes you from also having applications that speak in terms of they're just stupider, like go forward 10 units of whatever?
I think you know my answer. It absolutely does not preclude it. My children, I can tell them wash the dishes and hope they'll do it. And I can also tell them take this dish and move it from, 10 inches to the right. And again, hope that they'll do it. But when we're building, I don't know, let's call it a minimal viable architecture, which can be shared between rovers, we have a level of complexity caused by the fact it's positive. Okay, I see it as being positive, that each one of us has a different rover in mind. So one solution is to have very clear and then detailed specifications and abilities. But the other solution is to find something more minimal, like Eric said, when in doubt, do less. More minimal, which is still interesting. Okay, so if we can define a language which is maybe not as low level as move 10 steps forward, but is interesting enough, let's say, find green objects, okay, and take pictures of them. So I think that's what we should be doing. And leave the questions of what is type of language suitable for movement instructions, I'd leave that for later.
I think what I'm hearing is we should tie the level of abstraction and those particulars of the API to the actual task that we're trying to accomplish. And so we actually need to decide on what that is. Before you
You
can
are
do much else.
you're hearing at least me correctly.
Yeah.
Just one word, it's not task, but tasks in the plural.
Tasks.
Okay, but yeah, I agree. So maybe to rephrase what you're saying, we start from the tasks, and then we ask ourselves what type of language is suitable for defining this family of tasks, and then say, okay, can we build an API that translates them into each one of the particular 5 rovers we have, and hopes that we actually get something more general in the end. Yeah.
So just a side note is that I totally agree with that. That's why from the beginning of the year, I was suggesting maybe to find a scenario for field testing. Okay? It's like a target, a joint target on which we do what is needed and maybe only what is needed and no more. Okay, but at the same time discuss around that to see whether we can see what's coming and try to work. So I also totally agree with this kind of approach, at least for the frame of this year. We're already 1 hour in, and just I just wanted to have a quick look at the breakdown that you can see here. Okay, you can also see my screen still. Huh? I assume yes. Okay, it's just that especially this part. Okay, so the top left. Okay, the column on the left is basically the same as what we were looking at so far, but there is now the com box explicitly added on top. And I just wanted to quickly explain. Okay, that the next column I try to give more concrete detail. Okay, where the comms is basically okay what Rhett has been talking about in the GitHub thread. Okay? The controller, and so I replay the word app for controller because I was seeing some confusion myself as well. Okay, I use it here. Okay, it's basically the rover logic. So, for example, we have the scenario of follow green objects. Okay, that would be the controller. Okay? To say what to send commands to the rover to do what it has to do to follow green objects. The API is so let's say the framework, the SDK, okay, to program the controller. The adapters are adapting the API, the abstract API to the actual build, and the build is the CPU, the sensor actuator, and should add maybe the operating system as well. Okay. But after, if we, I try to see whether I can scope that down and make it more concrete. That's the next column. And so first is to look at what is per build and what is common, and also to look what is needed for all builds and what is optional. Okay. And so, of course, a build is per build and it's needed because we need the body. Okay. The adapter is also per build and needed. That's the point of the adapter. The API is common. Okay, so ideally we write it once or we specify it once. We implement it in several languages, and it's needed. On top of that, we have the controller where I break it down in 2 parts. One that is common and needed, and typically it's something like energy tracking. So imagine laptop, and every laptop, what all laptops have in common would be here, common and needed. Typically is to look at the battery level. And when battery is getting low, we have to notify the user that he needs to plug, okay? And so here, it's when energy is low, the rover must be able to get back to interrupt the application and say, okay, I can't follow green objects anymore. I need to go back to the base station. Otherwise, I can't fulfill my goal beyond that point. Okay? So this is the common part, and that's, I think, needed. And there is something that is either common or per build. So common is the common app. Okay. So for example, all our laptops have I don't know, an email app. Okay, so do we have the email app for rovers? I'm not sure. Okay. It can also be built to have all the specific apps. Like mine is following green objects, and the other one is following birds for some reason. And this is optional. Optional in the sense that there is the command needed part that is already there. Okay, that is basically about the survival of the robots. Beyond survival, there are apps if we want, basically. And the last brick is the purple one about communication. And that, I would say it should be common, because if you don't have a common protocol, it's difficult to communicate among rovers. Possible, but more work, and I think it's out of scope. And it's optional in the sense that it's only for collaborative rovers. And so the last column, and I will stop here basically, is a bit more concretely, I try to identify what could be the components that we make. So if I start at the beginning, so blue is basically the hardware, but also the operating system. Okay? The red is about the adapters. So that's build specific implementation of the API. Okay? In yellow, it's the API itself. So what are the actions that all rovers should have in common? So for example, forward, backward, maybe turn, maybe do rotate. There is also the ground clearing. Okay, so for example, with the spiders, we can change the clearing, right? Okay, things like that. Energy events also, for example. Okay. Those could be standardized in a way. After inside the common part of all controllers, there will be maybe what I call the energy event loop. Okay, so it's basically a program inside the rover that just checks the energy. And when energy is too low, to trigger some behavior. So for example, okay, we have a new goal is to go to the base station, and it takes top priority. On optional and common controller, there is something about the messaging API on which, for example, on top, the API defined by Red on GitHub could be implemented. Okay. So what I wanted to show here is something like how it could be. My goal is to try to see whether we can isolate software components, and depending on interest and skills, either interest is for some of us to develop them, and maybe for some of them to use them. Okay, and so to have this feedback loop inside the group, so that we can refine and learn and improve basically. And so a last word is that I try to keep the color scheme and my poor skills with this Figma tool. Okay, to try to put together this structuring idea of this architecture idea. Okay, so I don't want to take too much time. If there is interest, I can talk about it now. Okay, it maybe takes 5-10 minutes to get through. Okay? But it's this one in the middle. And the last one is I'm trying to start to list some concrete actions that we could just pick if we're interested in, or refine or break down and stuff like that. Food for discussion, basically. And I'm done with my last comment. Is that on the top right, I was starting to do something, but I'm having trouble with Figma. This is an extract of number 2, okay, where I remove a whole part. The whole part is the communication part. It's the REST API and the message event loop, basically. Okay, it's to show that the architecture without communication, so for a rover that doesn't need to communicate, would be much simpler. And I thought that was maybe easier to explain at first. Okay, so sorry, that was perhaps hard to digest. Quick go through what is inside the document. There's interest to discuss now, or perhaps later, or we ditch everything and we start from scratch.
Eric, I do have a quick note. If you can go back to that set of boxes that you had, the ones
Sure.
with,
Yep.
yeah. So I did implement something like this with my first rover. I was kind of limited by the hardware there. The difference between the models the difference between your model and what I did is I actually deliberately put the communications below the controller. So I made sure that there was a unified way of communicating with the rover, regardless of whether the communications were local or whether they were across the network. So it was basically a local network connection if it was being controlled from the rover itself, like the rover's brain was doing it, or it was being controlled by something over in DigitalOcean. So it meant that the comms API, adapter, and build were all local to the rover, and the brain, the controller, was above the comms in essence and could always talk regardless. I could see real differences with latency issues between remote and local, but it did, on a practical level, it meant that it made things pretty easy to move around where at least anything that was above the comms.
Yes, thank you. So that's very important and very in line with what you said earlier when you mentioned the API. Could be the API as it's written here, the yellow block was a web server. Okay, so here comes is something more how to say autonomy oriented, in the sense that the web server that hits directly the yellow blocks, the API. Okay, and let's forget about the controller. Okay. That's great, and it's compatible with this interface, with this description, because first it's optional. In this terminology, it's optional, in the sense that here the API is internal. Okay, it's about, as an autonomous entity, it has to drive, so it uses its own API. But we can export that API to a web server that we can do remote control. Great, okay, and that would be same as you. However, here the const means something a bit different. Is that it's about how to communicate with the controller, okay, with the brains, okay, and to communicate what we want. So the comms is kind of doesn't bypass the controller on purpose, okay, and we can see that in a bit in the infrastructure here, the architecture here, okay, that the purple box is where the messages come, okay. The blue is the hardware, so some Wi-Fi, we will receive a message, okay? And this enter a message queue in the message event loop, okay? And so here there is some interpretation, but after it hits the core event loop, okay, where decisions are taken, okay? And this is important because some messages can say, okay, go to the corner of the room. And let's say the brain of the rover gets that message. Okay, oh yeah, I got a message. I should go to the event to the corner of the room. But at the same time, internally, there is an event from the energy event loop that says, oh, it's the battery is low, and we have to do something about it. Usually, the energy management is gets priority. If we can bypass this mechanism, then we can tell the rover, go to the corner, whatever your energy level is. Okay, it's I don't care about your energy level, and the rover may just fail to do that because it did not take autonomously didn't take the initiative to override in a way to override or to reorganize its actions so that it can fulfill the goals. Victor, did I succeed in any way to clarify the difference and why comms is on top of the controller here?
Partially, I'm going to have to look at it a little bit more.
I think between the two of you, what I'm getting is that part of comms should be below and part of comms should be above, because it's almost like social actions, which is what allowing the rover to be commanded over the network is. social actions have a certain sort of survival priority level, and there might be some times when you kind of want to override the rover's own ideas about what high priority is. Other times, like energy management, the local rover should have priority. And this reminds me kind of like, if you remember Maslow's hierarchy of needs, you've got like survival at the bottom, and then belongingness is somewhere in the middle. So social and belongingness, and then self-actualization is on the top. So if you apply that to rover architecture, survival needs will trump social needs, as in listening to what other rovers want you to do. But self-actualization kind of like is above that even, and it can sort of be preempted by like social needs, something like that. So you can map self-actualization to the rover's own idea of what it wants to do with its life.
So I totally agree with that analysis. I think we need both. Okay. I just wanted to explain why comms is on top of controller here. That what Victor suggests would be basically a web server that hits directly into the API, bypassing the purple and green layers. Okay? Which is totally fine, because we can imagine we have a self-driving rover, and at some point we want to remote control it because we don't want to talk to it. We just want to have fine control, direct control about what it's doing at this point.
Final comment on this point, at least from me. One way to distinguish between control above comms versus control below comms is control above comms kind of participates in an economy of prioritization. So it can be that we can, if we have like a blockchain type mechanism at the prioritization level, and nothing is super critical like energy management or like security, and it's like, I want myself to go look for green objects, but my neighboring rover wants me to go look for birds, then the two kind of compete with each other in no particularly important priority way, and whoever pays more gets control of the hardware. And that kind of like stuff can live above the control layer. But if it is like, all right, you either go recharge your battery or the whole thing dies, then that is below the economy. So you can kind of like do a government regulatory kind of mapping here. So functions which the government does, like, defense and policing, they kind of like they precede economics, and there's functions that are done by the market that come after economics. So maybe that's the right way to partition the sort of task space into above and below layers of control.
Mm-hmm.
Sorry.
I like that very much. Oh, sorry, please. No, so someone was about to talk, right?
I don't know, but I can be about to talk. I just want to say that maybe what Victor ends up with his is that, like, maybe there's no difference between an API and a controller, and you can just merge those concepts to say, like, here's a capability that the rover has. You need a way to interact with that capability, so you got to throw some sort of communication mechanism to get to it. And that controller is either move forward for 10 seconds or whatever, or it's find pictures of green things or find green things and take pictures of them. And from the architectural perspective, they could be the same thing, even though obviously some are vastly more complicated than others. And most controllers are going to need other controllers to be able to do their jobs. And maybe that conceptual framework kind of solves both what Victor is thinking and what Mayor is thinking.
One, I guess, other way to think about it, there's, I think, at least one design for a robot where there's no real centralized coordination mechanism, yet it's actually pretty good at moving over rough terrain. Does anybody recall the video of that thing? It was pretty good at it. But I'm, that function there, which is very much decentralized from having any sort of brain for navigation, if that was the only thing in charge of the rover, it would not necessarily know what its battery state was or be able to act on it or anything like that. So maybe the function of what we talk about as a brain is to understand the different elements of what are in this rover, like the fact that it has some legs and then it has a camera and other things like that. So the brain part may be the thing that keeps the overall picture in mind. Does that make sense, as opposed to like, any other perspectives on this, or useful?
Oh, it does. It does. It frames a lot of what the rest of the system can do, to know what it is made of, right? Its configuration. It's like a configuration file in a way, right?
Mhm.
So by that, Victor, you mean that that would be in a way something that is in the controller green box and not in the yellow box, if I can put it in those terms.
Right. Like maybe the yellow box it definitely talks to the individual elements, and the individual elements are defined at a lower level or exist at a lower level. But in order to know that the battery is at a certain level and some action should be taken, or that we're looking for those things that are colored green, all those things have to be taken care of at a higher level than the individual components themselves. So
so the controller needs to be aware that they exist. Oh, sorry.
Yeah. So basically the brain would be the self-aware element, or relatively self-aware, and maybe other aware element of the rover, like the social aspects of it communicating with other things.
Maybe even less. Maybe the brain only needs to know your battery level. Why does it need to know you have legs? It says, gee, I want to walk somewhere, and the legs, walk somewhere. Like an octopus, kind of like herding cats. Each part of the rover is a cat, but if something needs to be done, the brain says, hey, cats, let's go somewhere, get some food. I'm sure there's a continuum, definitely if you look at sea animals in how centralized the control is.
Mm-hmm.
But yeah, I in general agree with this concept. I'm not saying all rover should be like that. I'm saying it's a viable concept for a rover. Let me just say another sentence. Let's say we have wheels, and let's say each wheel has a mechanism of knowing, where it's going. Is it going straight or is it sliding? And the rover the wheels start doing whatever they want to do. If the wheels have some mechanism by which they want to be more efficient, then they will align themselves with what other wheels are doing, and the rover will go in some direction. So you don't have to be aware of what's happening. All you have to have is some basic mechanism and communication. What I described as communication through the environment. Okay, it's not between each other, and you have a viable rover.
Mm-hmm.
And by the way, I think that's what ants do. Okay, if I have a group of ants, that's all they have. Teeny bit of communication between each other, but mainly communication through the environment.
And sorry, we are 5 minutes to the bottom of the hour. Would you have 5 minutes to discuss about maybe interest in a specific scenario we could do for a demo day? Why? Because as we mentioned today a couple of times, that perhaps that allows us to focus maybe on a subset of all the things we're talking about. But maybe that's a good thing, so that we can make progress and have concrete achievements to show is one thing, but also to think about before going deeper into maybe too big stuff. If you're okay, we talked about a couple of scenarios. They are on the notes of last week on how it's called, Rome. Okay, and so we talked about rover bingo, a rover high five, two rovers carrying the same object or doing something with the same object, which is pretty exciting. We also have a warm cold guess game. What else? We also had the multi-room race, kind of race, okay? Things like that. And so in the light of everything we've discussed today and previously, is there something that is in a way easy enough, impressive enough, but that also addresses a subset of the problems that we're interested in?
Yeah, I've been thinking about the scenario, and it seems to me that in the last few weeks, we discussed two kinds of scenarios. One is kind of like whimsical, fun games that look like, Clue, or show off like dramatic, fun possibilities that will be good for marketing. Like if we say we are solving a murder mystery that resembles Clue, chances are we'll get some interesting people on board. But on the other hand, I'm also sort of drawn towards making up a scenario that has at least some toy level relevance to roving. So personally, I'm leaning towards a more rover-like scenario, but with elements that kind of like get at the Clue kind of scenario as well. So one example I thought of would be, like imagine you've got like a new rover is coming to join the 5 that are already on Mars. That's our sort of setup. And it's crashed and burned in the atmosphere, and debris has fallen all over the place. So there's like maybe 5, 6 different parts, and we can represent this with like 5 or 6 little tokens with different barcodes or like recognizable vision shapes, like, and the job is like you want to go scavenge. And you need communication and coordination because there are like 5 or 6 pieces scattered around. And if rover number 1 finds piece number A in its sector, it can just broadcast to the rest that piece A has been found and I have it. The rest of you can stop looking for that, go look for the other stuff. So we can, I think, construct a scenario that has elements of like a fun treasure hunt or scavenger hunt type game, but also has like direct relevance to a rover-like scenario. What do people think of that?
Well, I think it would be fun.
Please.
I think it would be fun, and we could, for example, have each. If your rover can handle certain environments and it can't handle others, then your rover would be doing a parts search in an environment it could handle, and we could go from there.
Yeah, we talked about kind of creating a synthetic Mars where all the rovers live in their little own Mars yard, and then the synthetic map has like aligned edges so that virtually there's like a 9-segment map that's got a shared coordinate space, but really one piece is in Seattle, one piece is in Tokyo, one piece is in Israel. So that's kind of how we thought about it, I think 3-4 weeks ago. So that gives us kind of like a fun virtual environment to work with. Hey, we could even put it in VR, like run the mission in a way that is reflected on VR.
I said that I think it's very interesting to do VR for robots as a concept. So that attracts me.
I know 3 companies who trying to work on that in California and here in Tokyo over the past 3 years. So it's apparently perceived as valuable, but it's really tough.
Well, are any of those folks willing to come do it for free?
Yeah, it's a hard problem, but I think the enabling technologies are just about starting to get there. Like There's Decentraland, which is a decentralized blockchain virtual reality space. And I have a feeling we're getting close to where it'll actually be easy. Like many of the problems are not actually rover or robotics problems. Other people are solving like synthetic virtual world type of things, and maybe they'll get there fast enough for us to build on it. Like one of those simulation environments we've already seen, maybe they're already distributed. The one Anuraj is using. But,
I don't know if we did we I don't know if I shared this paper, but there was a paper from JPL about how rover ops changed during the pandemic. I don't remember if I posted in there, or if I found it in Discord or what, but one of the things that was interesting was how, because they have some custom hardware for some specific workstations that are needed, that those were like big stumbling blocks for moving things remotely. And one of them was they have stereoscopic glasses and a stereoscopic monitor for rendering some stuff in 3D for navigation purposes. And of course, at the time, not everyone has like an Oculus at home. So you need a lot of very special hardware to like make that work. But just a few years later, and it's just like, well, that's just a little Unity program in it. Fire it up in your Oculus for $200 and you're good to go.
I have a friend who's developing VR and AR apps for the Oculus, so I'll actually ask him how feasible or realistic this is. In fact, if there's interest in the VR angle, maybe we can find like a couple of people to come and talk to us about it. I can ask him if he's interested. So that might be fun to talk about. And yeah, I think the dynamic is exactly what Red said, that stuff that used to take super specialized hardware that you had to be in a command center for, now it's like random over the internet. Everybody can do it through a laptop kind of stuff. So something like that might be happening here, hopefully.
In terms of the big picture about what we are discussing now, a concrete output would be the demo day. Okay, so it's in December, so we still have some time. And the push recently is to try to come up with a rallying subject and maybe a bunch of tasks that we can spread over the rest of the year. It seems we do have some convergence, okay, but still a lot of pending questions. What do you think about? So next week we have an update from Venkatesh, I think. Yep.
Yeah. Hopefully, I'll still be able to.
Yes, Venkatesh. Yes, yeah. And the slot. Thank you, Venkatesh. And the slot after that is still open. Okay. And so, what do you think about? I don't know. It seems to me the discussions are interesting, and we are going somewhere. Okay. But I don't want to have maybe too high density of those meetings because it's already 3 weeks in a row. What do you think? I think we need to discuss more, okay? But also to think more offline. So I would propose to have a mission that we could converge on Discord is to identify a scenario we all want to do, okay? So for example, one involving VR or AR, okay? But we identify one or maybe a couple of them, and we use that to identify again, possibly offline or maybe mainly me, to identify what needs to be done to achieve that particular scenario at the minimum. Okay, and we can align that with what we have in terms of rover, in terms of software, and so on, so that we can basically identify the diff of what needs to be done until the end of the year. Does it sound like practical enough to step forward? You can complain that I'm using too many words. I do. Yeah.
And no, I think we are kind of starting to converge. This is way more converged than we were 3 weeks ago. And yeah, I think there's a couple of obvious starting points. One is to actually define this end of year demo scenario in like much more detail, like at the level of like something we can already work on. So that's one concrete thing we can start on asynchronously. And the other is I don't know, people signing up for like the implied pieces of it. Like, for example, if there's a shared map on which you're doing a shared search task, then somebody has to come up with like the API that has the minimum viable set of commands that can support that type of mission. So I think let's start with defining the mission. And then once we kind of have enough clarity on that, I think the second part will follow kind of naturally.
Okay, so concrete, based on that, what do you think about we create a thread on Discord to discuss this scenario, okay? And I'm in charge of taking notes and putting that together, okay? And we do the communication Discord, and I see two open slots. It's April 19th and 26th. After that, all slots are taken by one of us, okay? And so in one of these two slots, we perhaps we can have an invited talk. Venkatesh, if we can reach your VR friend, and the other one we can try to work on that scenario, on breaking it down and identify what needs to be done. So Discord discussion, and we meet again this month to talk about what we do.
Sounds good.
Cool.